Imagine for a moment that you could capture all the sun's energy, not just a little bit through solar panels, but literally all the energy our star produces every second. We're talking about 3.8 times 10 watts of power. To give you an idea of this absolutely mind-boggling magnitude, that's 4 trillion times more energy than all of humanity currently consumes. And what if I told you there's a scientific classification for civilizations that can do exactly that? And that perhaps, at this very moment, there are civilizations in the universe building structures the size of entire solar systems to capture that energy. Welcome, cosmic explorers, to another journey through cosmic frontiers. Today, we're diving into one of the most fascinating concepts in astrophysics and the search for extraterrestrial life, the Kardashev Scale, and the super-advanced civilizations that might exist in the cosmos. You'll discover what it truly means to be a Type 2 or Type 3 civilization. Learn about the most impressive megastructures ever imagined by science. Understand how scientists are literally scouring the universe for signs of these colossal civilizations, and explore the new ways researchers have developed to classify a species' technological power. Get ready, because by the end of this video, your perspective on what's possible in the universe will never be the same. We're on an incredible journey towards our first 1,000 cosmic explorers, and each one of you is part of this shared discovery of the universe's mysteries. So buckle up, because today we're traveling to a future where cosmic engineering completely redefines what it means to be an advanced civilization. Our story begins in 1964, when a Soviet astrophysicist named Nikolai Kardashev was pondering a fascinating problem: how to classify civilizations based on their energy consumption. Kardashev realized something brilliant. The energy a civilization can control and utilize is fundamentally what determines its technological capabilities and its power to transform the universe around it. Let's start by understanding where we, humans, fit into this scale. Currently, we are a Type 0 civilization. That's right, we haven't even reached Type 1 yet. We consume about 15 terawatts of energy, which seems like a lot until you discover that a Type 1 civilization consumes 10,000 times more energy than that. To put it in perspective, imagine your electricity bill. Now imagine you could use all the energy from every lightning strike on Earth, from every earthquake, every volcano, every wind, and every ocean current simultaneously. That would be a Type 1 civilization, a species that can harness all the energy available on its home planet. But this is where things get truly spectacular. A Type 2 civilization can capture and utilize all the energy produced by its star. And when I say all, I mean all of it. To achieve this, they would need to build what scientists call megastructures, constructions so gigantic they defy our comprehension. The most famous of these megastructures is the Dyson Sphere, proposed by physicist Freeman Dyson in 1960. Imagine a gigantic sphere built around the sun, capturing absolutely all its radiation. But here's an important detail that many people don't understand. Dyson never proposed a giant solid sphere that would be impossible to build and structurally unstable. Instead, he envisioned a swarm of solar collectors orbiting the star, millions or billions of specialized satellites designed to capture solar energy, forming a cloud around the star. To give you an idea of the scale involved, each of these collectors could be the size of entire countries. The amount of material needed to build a Dyson sphere would be equivalent to dismantling entire planets. In fact, some scientists suggest that an advanced civilization could literally dismantle rocky planets like Mercury, using the materials to construct these colossal solar collectors. Now, pause for a moment and think. If you were an astronomer observing a star from afar, and suddenly, it started to dim and emit more infrared radiation, what would you think? Exactly, you would possibly be observing a Type 2 civilization building its Dyson sphere. But Dyson spheres are just the beginning of the possibilities for a Type 2 civilization. They could build space habitats the size of continents, move entire planets from their orbits, or even reconfigure entire solar systems to optimize energy production. We're talking about engineering on a scale that makes our biggest constructions look like set. And then we get to Type 3 civilizations. And here, my cosmic explorers, we enter territory that borders on science fiction, but is completely grounded in real physics. A Type 3 civilization can harness the energy of an entire galaxy. This means they would have control over hundreds of billions of stars. To achieve this, they would need technologies that we can only dream of: mass interstellar travel, instantaneous communication across galactic distances, and the ability to coordinate engineering projects that span tens of thousands of light years. Imagine structures connecting entire star systems, energy networks stretching across complete galactic arms, or even the ability to reposition stars like pieces on a cosmic chessboard. A Type 3 civilization could, literally, redesign the structure of an entire galaxy. But here arises a fascinating question. How on earth would we detect such advanced civilizations? The answer lies in something scientists call technosignatures, technological traces that leave observable marks in the universe. For Type 2 civilizations, the primary technosignature would be the stellar light absorption pattern. A star partially enveloped by a Dyson sphere would show strange and specific dips in its brightness, especially at certain light frequencies. Additionally, it would emit much more infrared radiation than normal, as the solar collectors would re-emit the captured energy as heat. Astronomers are already actively searching for these signs. Projects like Breakthrough, LISTEN and astronomical surveys analyzing data from the Kepler telescope have looked for stellar dimming patterns that could indicate megastructures under construction. So far, some stars have shown strange behaviors, like the famous KIC 8,462,852, nicknamed Tabby's star, which were even considered candidates for harboring Dyson spheres, although natural explanations were later found. For Type 3 civilizations, the technosignatures would be even more dramatic. We might observe entire galaxies with anomalous energy emission patterns, regions where stars appear to have been rearranged into unnatural configurations, or even communication signals on galactic scales. Some researchers suggest looking for galaxies that emit much more infrared radiation than they should, which could indicate massive energy use by a galactic super. Now, you might be asking, are these Kardashev classifications sufficient to understand all the possibilities of advanced civilizations? The answer is no. Science has evolved greatly since 1964, and new types of classification have been proposed. Carl Sagan, the famous astrophysicist and science communicator, proposed a more refined scale that considers not only energy consumption, but also a civilization's information processing capacity. On this scale, we humans would be a Type 0.7 civilization. We already process impressive amounts of information, but we are still energetically primitive. Other scientists have proposed classifications based on spatial control. A Type 1 civilization would control its planet, a Type 2 would control its solar system, a Type 3 would control its galaxy, and a hypothetical Type 4 would control a galaxy cluster, or even significant regions of the observable universe. There is also the Barrow scale, which classifies civilizations by the smallest scale at which they can manipulate matter. We humans manipulate matter at the molecular scale. A more advanced civilization could manipulate individual atoms, subatomic particles, or even the fundamental structure of space-time. And here we come to a truly unsettling reflection. Where are all these civilizations? If the universe is 13.8 billion years old, more than enough time for civilizations to evolve to these incredible levels of technological development, why don't we see clear evidence of them everywhere? This is an expanded version of the famous Fermi paradox. Perhaps super-advanced civilizations use forms of energy that we do not yet understand. Perhaps they develop in ways that make their detection impossible for us. Or perhaps, and this is a possibility both fascinating and terrifying, perhaps there are evolutionary filters that prevent most civilizations from reaching these levels of development. Some theories suggest that truly advanced civilizations might completely transcend the need for physical megastructures. Instead of building Dyson spheres, they could discover ways to extract energy directly from the quantum vacuum, or even from black holes through the Penrose process. In this case, their technosignatures would be completely different from what we are looking for. There is also the intriguing possibility that super-advanced civilizations practice something scientists call subtle astroengineering. Instead of building obvious megastructures, they could modify stellar systems in ways that appear natural to less advanced observers, but which actually represent unimaginably sophisticated cosmic engineering projects. Imagine, for example, a civilization that can slightly accelerate the evolution of stars to optimize their energy production over billions of years, or that can gravitationally manipulate entire planetary systems to create ideal conditions for life. To us, this would seem perfectly natural, but it would actually be the result of planning and technological execution. that goes far beyond our current understanding. Another fascinating aspect is the temporal question. Type 3 civilizations operate on galactic timescales. Their projects can take millions or even billions of years to complete. For such a superintelligence, the difference between 1,000 years and 1,000,000 years can be irrelevant. This means that evidence of their activities can be extremely subtle when observed on human timescales. And here we come to a possibility that truly messes with our perception of reality. What if we are already within the area of influence of a super-advanced civilization, but simply lack the capacity to recognize it? Just as ants in a garden don't understand that they are living in an environment modified and maintained by a higher intelligence, perhaps we are living in a region of space that has been modified or is monitored by a Type 3 civilization. But our technology and understanding are insufficient to detect this influence. The search for technosignatures of advanced civilizations is becoming an increasingly active area of astronomy. New telescopes like the James Webb Space Telescope have unprecedented capabilities to detect anomalies in distant stellar systems. Future projects, such as the Extremely Large Telescope, will have sufficient resolution to potentially detect megastructures in nearby stellar systems. Furthermore, the development of artificial intelligence is revolutionizing our ability to analyze astronomical data. Machine learning algorithms can identify patterns in astronomical datasets that would be impossible to detect manually, potentially revealing technosignatures that have gone unnoticed until now. Recapping our cosmic journey today, we discovered that the Kardashev Scale classifies civilizations by their energy control, from planetary civilizations to galactic superintelligences capable of controlling hundreds of billions of stars. We explored the incredible megastructures these civilizations would build, especially Dyson Spheres that could capture all the energy of a star. We saw how scientists are actively searching for signs of these civilizations through technosignatures, and discovered that new forms of classification consider not only energy, but also information processing and spatial control. But perhaps the most impressive thing of all is realizing that our search for advanced civilizations is fundamentally a search for our own potential future. Every concept we've explored today, from Dyson Spheres to galactic astroengineering, represents not only what others might have achieved, but what we ourselves could one day accomplish. This leads us to a profound reflection on our place in the cosmos. If civilizations like these exist, we are like children taking their first steps in a universe filled with unimaginably advanced intelligences. And if they do not exist, perhaps we are destined to become the cosmic architects of the future, the first to transform dead matter into consciousness capable of reshaping entire galaxies. Cosmic explorers, here is my question for you in the comments. If you could ask a Type 3 civilization one single thing, what would it be? And do you think such an advanced civilization would still remember what it was like to be a planetary species like us? Leave your thoughts in the comments. I love reading every one of them, and they often inspire future episodes. And since we're talking about the future, what mystery of the universe do you want me to talk about in the next video? Wormholes, dark energy, the possibility of parallel universes. Leave your suggestions. We're on an incredible journey towards 1,000 cosmic explorers. If this video expanded your perspective on what's possible in the universe and made you imagine incredible futures for our species, join our crew by clicking subscribe. Like this video if it sparked your curiosity about cosmic civilizations, and share it with someone who is also fascinated by the infinite possibilities of the cosmos. In the next video, we'll explore another fascinating mystery that connects quantum physics with cosmology. Stay tuned. Until then, keep looking at the stars and remember that every point of light in the night sky could be home to a civilization that has transformed an entire galaxy into its technological masterpiece. The universe is stranger and more wonderful than any of us can imagine.